Hi everyone, this is video 10 in our series on Pythagoras and trigonometry. In this video, we are looking specifically at angles of elevation and depression. There is no new mathematics as far as we're concerned. We're simply applying it to worded problems, and we're going to need to draw the diagrams in this situation. So let me start by showing you a picture. So these could be two people standing on two different buildings, two different cliffs, with one person who is lower looking upwards at someone who is higher. Conversely, we could have someone who is higher up looking down at the lower person. And if I draw this diagram with horizontal lines for the eye level of each person, and a line joining one person to the other, I can give a name to these angles. I could call this down here the angle of elevation. For the person who is looking down, I could call this the angle of depression. So elevation means up, and depression in this context means down. And I want you to notice that the angles are measured with respect to the horizontal. So a very common misconception that students have when learning this for the first time is they try to measure this angle, which I'm marking in orange here. Here's the orange. So they'll measure this angle. This is an angle, but it's not the angle of depression. So just please make careful note of that. The angle of depression is measured to the horizontal. So you need to have a line from left to right when measuring this angle. One more thing I want to say before we do an example is that the angle of elevation and angle of depression in this diagram are the same. And this might surprise you. So the reason why they're the same is because of a property that you meet in year 8 geometry. And that is if I have two parallel lines, angles labeled like such are equal. I forget the name. I believe this is called the alternate angle property, and those angles are the same. So this diagram here in green is actually what's happening here, and that's why the angle of depression and the angle of elevation as shown are the same. All right, let's do a couple of examples. So I'll give you a moment to read that. Feel free to pause the video if needed. The key information here is that we are told someone is 1.4 meters tall, and they are viewing a building which is 50 meters away, and the angle of elevation is 60 degrees. Elevation should be spelled with an E, by the way, not an A, so I'll just change that. Yep, spelled it correctly on that slide. Okay, and what we're asked is, how tall is the building? So when you are solving an elevation or depression problem, the first thing you want to do is to draw a diagram. So let's do that. We've got a person who is viewing the top of a building and the angle of elevation is 60 degrees. Of course, this forms a right-angled triangle, and we can label some heights. So this height from ground level to eye level is 1.4 meters. And this distance here along the ground is 50 meters. So, in other words, Jill is 50 meters away from the base of the building. Now, what we are being asked to find is this height, which I will call h. But h is not in the right angle triangle. What we actually have is this. So as long as you're consistent, you can say, you can call that h, but then you'd have to add 1.4 meters to your answer at the end. So it's up to you whether you choose to give this quantity a different letter or to call this h and add 1.4 meters to your answer. I'm just going to call this d for some unknown distance, and then I'll add 1.4 at the end. So our goal is to find h, and in order to do that I need to find d first. So here's my right angled triangle. You don't have to draw it, but I've got d, I've got 50 meters, and I've got 60 degrees. And I've got a situation where I have O and A. So the trigonometric ratio I should use is tan. Tan of 60 equals d divided by 50, or opposite over adjacent. But I'm not going to write that now because you've got plenty of experience with trigonometry. So now I can rearrange this equation for d by multiplying both sides by 50. So d equals 50 times tan of 60 degrees. But don't stop here, because we don't want d, we want the heights of the building above ground. So h is equal to 1.4 plus d, or 1.4 plus 50 times tan of 60 degrees. And at this point, you're going to need to get a calculator. So here's my calculator. 1.4 plus 50 times tan of 60. And I get 88.00 meters to 2 decimal places. Okay, I haven't said how much to round to in this question, so if you're not told how much to round, just choose something sensible. In an assessment, you'll be told how precisely to do your rounding. Before I move on, I'll just say one more time, please note, do not stop here at d equals 50, tan, 60. You need to finish off the question and calculate the height above ground, not the height above eye level. Okay, one more example. So I'll give you some time to read the question again. Feel free to pause the video if it's helpful. The key information we are given here is that this time we are viewing from a height 100 meters above ground. We are looking at a tree that we know is 20 meters tall. And because we're looking down, this time the angle of depression is 40 degrees. And again, the question that we are being asked is, how far away is the tree along the ground? It's going to be very hard to solve this question without a diagram. So let's go ahead and do that. So here's Jill, probably on some sort of cliff. And we have a tree. So here's our right-angled triangle. So if we know that the tree is 20 meters tall and eye level is 100 meters above ground, then this height here has to be 80 meters because 100 minus 20 equals 80. See how I calculated something that wasn't given in the question? Sometimes you have to do that in an elevation and depression problem. Now, we are also told the angle of depression is 40 degrees. Please be very careful to label the depression angle in the right place. It's here. Remember, the elevation and depression angles are measured to the horizontal. So in this triangle, that angle is 40 degrees. And what we're solving for is this distance, which I will call D. How far away is the tree along the ground? So here's D, here's 80, and the angle is 40 degrees. If I want to, I can label the sides of the triangle again, O and A. And since I've got O and A, the trigonometric ratio I want to use is tan. So tan of 40 degrees equals opposite over adjacent, or in this case 80 divided by D. And you'll remember from a previous video, if D or the pronumeral was in the bottom of the fraction, what we want to do is swap that number with the trigonometric ratio. So I can write D equals 80 divided by tan 40. If you're unsure how I got that step, I've skipped a step, and I could say D times tan 40 equals 80. To go from this step to this step, I multiply by D on both sides. And then to go from this step to this step, I divide both sides by tan 40. Okay, but you are welcome to go straight from this line to this line if you're not comfortable with the algebra. All right, let's go ahead and calculate this. So it's 80 divided by tan 40. and that gives us 95.34 to 2 decimal places. So I should say that we should give a unit in our answer. So the distance is in meters because our quantities were measured in meters. So really, I should say 95.34 meters. And in the previous question, I already put meters in as well. If you want, you can answer questions like these with a sentence at the end. So you could say, the tree is 95.34 meters away. And that would be a better answer. So instead of just writing down a number, write a sentence that specifically addresses the question that's asked. I'm not going to make it a requirement this year, but it's a good habit to get into for future years, especially in VCE. And I'll try to start modeling that in future videos. So let me just wrap up by saying our general approach to solving elevation and depression problems is as follows. The first thing you want to do is draw a diagram. If you don't draw a diagram, it's almost impossible to solve these questions. Next, you want to label the diagram with relevant information. Since we are doing trigonometry, the relevant information is angles and side lengths. The next thing you want to do is work out what is unknown. That is the quantity that you are solving for. And then you'll want to set up and solve an equation for what is unknown. Generally, at this step, you will use trigonometry, either to find an unknown side length, as we did in the 2 examples, or an unknown angle. The best way to develop your confidence with problem solving is to practice. So for something like this, you've really got to do questions to get comfortable with this. So if you're not feeling comfortable after watching this video, that's pretty normal. Do some questions, and I think you're going to feel better about this. See you next time.